Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Instead of jumping straight into cloud terminology, imagine you're starting a new business. Your team needs a website, a customer database, file storage, email, backups, and enough computing power to support future growth. One option is to buy physical servers, networking equipment, storage systems, backup hardware, software licenses, and everything else required to build your own data center. Another option is to rent those computing resources from a cloud provider and begin using them almost immediately. Neither choice is automatically right or wrong. Large organizations still operate their own data centers for some workloads. But for many businesses, renting computing resources provides greater flexibility, faster deployment, and lower upfront investment. That simple idea, renting computing resources instead of buying and operating everything yourself, is the foundation of cloud computing. Today, you'll learn what cloud computing really is, how it works behind the scenes, and why understanding it has become one of the most valuable skills in modern IT. By the end of this lesson, you'll be able to explain cloud computing in plain English without relying on buzzwords. You'll understand why organizations move many workloads to the cloud, how cloud providers deliver computing resources over the internet, and the key characteristics that make cloud computing different from traditional infrastructure. Most importantly, you'll know exactly how to begin practicing cloud skills using free learning resources and cloud trial accounts. Whether your goal is Helpdesk, system administration, cybersecurity, software development, or cloud engineering, this lesson builds the foundation you'll use throughout the rest of this masterclass. The simplest, most stick-in-your-brain definition: cloud computing is renting computing power, storage, and software over the internet instead of buying servers and running them in a closet. It's like getting electricity from a utility. You flip a switch, the lights come on, you don't build a power plant. Same idea. You log on, your apps and data are there. Here's the big picture. You send a request from your laptop or phone. It travels over the internet and lands inside a massive data center, a climate-controlled warehouse packed with thousands of servers, storage arrays, and databases. All that hardware sits in the provider's facilities, not under your desk. You just access it whenever you need it. Before we go further, let's lock in the big idea. Pop quiz. What is cloud computing at its core? The answer: it's renting IT resources over the internet instead of buying and maintaining your own hardware. If you said anything like pay-as-you-go or on demand, you're on the right track. Before cloud computing became common, deploying new infrastructure was often a slow and expensive process. Organizations purchased servers months before they were needed because hardware had to be ordered, delivered, installed, configured, tested, and connected to the existing network. They also had to estimate future demand. If they underestimated, applications slowed down during busy periods. If they overestimated, expensive hardware sat idle for years. After deployment came the ongoing work: installing updates, replacing failed components, managing backups, expanding storage, upgrading operating systems, maintaining cooling systems, and ensuring reliable power. Cloud computing didn't eliminate these responsibilities. Instead, it shifted many of the physical infrastructure responsibilities to specialized providers so organizations could focus more on the applications and services that create value for their business. Let's compare these two approaches. With traditional on-premises infrastructure, your organization purchases the hardware, installs it in a data center, powers it, cools it, secures it, monitors it, repairs it, and eventually replaces it. With cloud computing, the provider operates the physical infrastructure. Your organization rents the computing resources it needs and accesses them over the network. Need another server? Instead of waiting weeks for new hardware, you can often provision one in minutes. Need additional storage? Increase the capacity through the management portal instead of installing new disks. Need more computing power during a busy period? Many cloud services can scale to meet demand without requiring you to purchase permanent hardware. The cloud changes how infrastructure is delivered, allowing organizations to obtain computing resources much more quickly while reducing the need to manage physical equipment. Cloud computing is no longer an emerging technology. Organizations of every size, from small businesses to global enterprises, use cloud services every day to host websites, run business applications, analyze data, collaborate with employees, and deliver services to customers. Instead of asking whether companies should use the cloud, today's discussions usually focus on which workloads belong in the cloud, which should remain on-premises, and how to integrate both environments securely. Understanding cloud computing is no longer a specialized skill. It has become part of the foundation of modern IT. Time to lock it in. Take a second. Can you define cloud computing in one plain English sentence? Pause if you need to. Ready? Here's the answer. Cloud computing lets you rent computing resources, servers, storage, databases, software, over the internet, paying only for what you use, instead of buying physical hardware you have to manage yourself. Cloud computing would not exist without virtualization. Traditionally, one physical server ran one operating system and one primary workload. Much of that expensive hardware remained underutilized. Virtualization changed that. A special software layer called a hypervisor allows one physical server to run multiple, independent virtual machines at the same time. Each virtual machine behaves like its own computer with its own operating system, applications, memory, and storage, even though it shares the underlying hardware. This allows cloud providers to use hardware far more efficiently while securely isolating customers from one another. Combined with resource pooling, automation, and high-speed networking, virtualization enables cloud providers to deliver computing resources in minutes instead of weeks. Understanding virtualization makes cloud computing much easier to understand because it explains how thousands of customers can securely share the same physical infrastructure. Picture a retail site. On a normal Monday, 10 servers handle the traffic easily. Then Black Friday hits. Within minutes, the system automatically spins up 1,000 servers without anyone lifting a finger. When Monday comes back around, it drops right back down to 10. That's elasticity, expanding and shrinking on demand, so you never pay for capacity you aren't using. Earlier, we discussed elasticity, the ability to increase or decrease computing resources based on demand. One technology that makes this possible is an auto-scaling group. Think of it as a manager watching application demand. When traffic increases, additional virtual machines are launched automatically. When traffic decreases, unnecessary virtual machines are removed. The cloud provider constantly compares the current workload against the scaling rules you've configured and adjusts resources accordingly. Instead of purchasing enough hardware for your busiest day of the year, you can often scale resources only when they are actually needed. That's one of the biggest operational advantages of cloud computing. The National Institute of Standards and Technology, commonly known as NIST, defines 5 characteristics that distinguish true cloud computing from traditional hosting. First, on-demand self-service. Users can provision computing resources without waiting for someone to manually install hardware. Second, broad network access. Services are available over standard networks and accessible from many different devices. Third, resource pooling. Computing resources are shared securely among multiple customers using technologies such as virtualization. Fourth, rapid elasticity. Resources can scale up or down quickly to match demand. Finally, measured service. Resource usage is monitored, so customers pay for what they consume. These 5 characteristics appear regularly in cloud certification exams and technical interviews, making them important concepts to understand rather than simply memorize. Time for a quick check. Name 2 of the 5 essential characteristics of cloud computing according to NIST. Think about how you access resources without waiting for IT approval. Got it? The correct answers are any 2 of on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Cloud computing is used across nearly every industry. Healthcare organizations store and analyze medical information. Financial institutions process transactions and detect fraud. Retail companies support online shopping and seasonal demand. Manufacturers collect data from equipment to improve production. Governments deliver online citizen services. Schools provide collaboration platforms for students and teachers. Although every organization uses cloud computing differently, the underlying technologies are remarkably similar. Once you understand the fundamentals of cloud computing, those skills become transferable across industries, providers, and job roles. Let's test your recall. Imagine millions of people pressing the play button on a streaming service at nearly the same time. The demand changes constantly throughout the day. Evenings are busier than mornings. Weekends are busier than weekdays. A new movie release can create a sudden spike in traffic across multiple countries. Instead of purchasing enough physical servers to handle the highest possible demand all year long, cloud infrastructure allows resources to grow and shrink as needed. This flexibility helps organizations deliver reliable services while using computing resources more efficiently. Streaming platforms are only one example. The same cloud technologies support online banking, e-commerce, healthcare systems, video conferencing, gaming, education, and thousands of other services people rely on every day. Cloud computing has transformed the way organizations build and operate technology. As more workloads move to cloud platforms, organizations need professionals who understand cloud infrastructure, networking, identity, security, automation, monitoring, and governance. That creates opportunities across many different IT careers. Helpdesk professionals support cloud services. System administrators manage hybrid environments. Security analysts protect cloud resources. Developers build cloud-native applications. Cloud engineers design and automate infrastructure. Learning cloud computing is not about chasing a trend. It is about building skills that apply across many modern IT roles. Cloud knowledge opens the door to many career paths. Cloud engineers build and maintain infrastructure. Solutions. Architects design systems that meet business requirements. DevOps. Engineers automate software delivery and infrastructure deployment. Cloud security engineers protect identities, networks, applications, and data. Platform engineers manage the environments developers use to build applications. Even traditional IT roles increasingly interact with cloud services every day. The important lesson is that cloud computing is no longer a separate specialty. It has become part of the core knowledge expected across modern IT. Several companies provide cloud services, but 3 providers dominate most enterprise environments. Amazon Web Services, commonly called AWS, offers one of the broadest collections of cloud services and is widely used across many industries. Microsoft Azure integrates closely with Microsoft technologies such as Windows Server, Active Directory, Microsoft 365, and Power Platform, making it a popular choice for enterprise organizations. Google Cloud Platform is well known for strengths in data analytics, artificial intelligence, machine learning, and Kubernetes. Other providers also serve important markets, including Oracle Cloud Infrastructure, IBM Cloud, and Alibaba Cloud. Although every provider uses different service names, the core cloud concepts remain remarkably similar. Once you understand cloud fundamentals, learning another provider becomes much easier. The best way to understand cloud computing is to experience it yourself. All major cloud providers offer free learning options, trial accounts, or free tier services that allow beginners to experiment with cloud resources. Creating an account typically requires verifying your identity using a phone number and, in many cases, a credit card. Verification helps prevent abuse of the platform. One important reminder: a free account does not mean every service is free. Always review the provider's current free tier documentation before creating resources. Monitor your usage and delete resources you no longer need. Developing good cost management habits is an important cloud skill. Let's make sure you remember the basics. When creating a cloud account, why might the provider ask for a phone number or credit card? The answer is identity verification. Cloud providers want to confirm that real people, not automated bots, are creating accounts. Before launching any services, always understand what is included in the free tier and what may generate charges. Responsible cloud engineers learn to manage costs from day one. Once you've installed a Cloud Command Line Interface, or CLI, you can communicate directly with cloud services. One simple command lists your storage resources. Another displays information about the account you're currently authenticated as. Although the commands themselves are simple, something important is happening behind the scenes. Your computer sends a secure request across the internet to the cloud provider's API. The provider verifies your identity, checks your permissions, processes the request, and returns the results. Every cloud portal, mobile application, automation script, and deployment pipeline ultimately communicates with cloud services through APIs. Learning the CLI helps you understand how cloud automation really works. One of the biggest misconceptions about cloud computing is that the provider is responsible for all security. That is not how cloud security works. Cloud providers secure the physical facilities, networking hardware, storage systems, servers, and much of the underlying infrastructure. Customers remain responsible for securing the resources they create. Depending on the cloud service, that may include operating systems, identities, permissions, applications, data, encryption settings, backups, monitoring, and compliance. The exact responsibility boundary changes depending on the service you're using, but one principle always remains true. Security is shared. Understanding where your responsibility begins is one of the most important skills in cloud computing. One of the first services every cloud professional learns is Identity and Access Management, commonly called IAM. IAM controls who can access cloud resources and what actions they are allowed to perform, rather than giving every user full administrative privileges. Cloud platforms follow the principle of least privilege. Each user receives only the permissions required to perform their job. For example, a developer may be allowed to deploy applications without deleting databases. A helpdesk technician may reset passwords without managing billing. A security analyst may review logs without modifying infrastructure. Good IAM design protects organizations from both mistakes and malicious activity. You'll learn much more about IAM throughout this masterclass because nearly every cloud service depends on it. Let's review what you've learned. When you run a cloud CLI command, what happens first? The command is sent to the provider's API. Before the provider performs any action, it verifies your identity and checks whether your account has permission to complete the request. If you are authenticated and authorized, the request succeeds. If not, access is denied. Cloud computing is not just about servers. It is equally about identity, permissions, and secure access. If you're serious about building cloud skills, here's a practical roadmap. During your first week, create a free cloud account, explore the management portal, and learn the basic terminology. During the second week, deploy a simple storage service or virtual machine and practice starting, stopping, and deleting resources. During the third week, explore identity management, create a few users or roles in a lab environment, and learn the principle of least privilege. During the fourth week, automate simple tasks using the command line interface or infrastructure as code tools. Keep notes on everything you build. Take screenshots. Document problems you solved. Delete resources when you're finished so you avoid unnecessary charges. By the end of the month, you'll have something much more valuable than memorized definitions. You'll have practical cloud experience. Many successful cloud professionals began in helpdesk or desktop support. They learned operating systems, networking, troubleshooting, Active Directory, scripting, and virtualization before expanding into cloud technologies. Cloud careers rarely begin with advanced architecture. They begin by mastering the fundamentals. A strong foundation in networking, operating systems, identity, security, and automation makes learning cloud services much easier. Don't compare yourself to someone with years of experience. Compare yourself to where you were 6 months ago. Consistent learning creates long-term career growth. Let's review the most important ideas from today's lesson. Cloud computing is the delivery of computing resources over a network, allowing organizations to access infrastructure, platforms, and software without owning all of the underlying hardware. Cloud providers operate massive data centers that use virtualization, automation, and resource pooling to deliver computing resources quickly and efficiently. Organizations choose cloud computing because it offers flexibility, scalability, and faster deployment while allowing them to focus more on delivering business value. Finally, you now have a practical roadmap for gaining hands-on experience using cloud learning resources and free tier environments. Those concepts form the foundation for everything you'll learn throughout the rest of this cloud series. Now that you understand what cloud computing is, the next question naturally becomes, what exactly are you renting? Sometimes you're renting virtual machines. Sometimes you're renting an application platform. Sometimes you're renting complete software. Those different service models are called infrastructure as a service, platform as a service, and software as a service. In the next lesson, we'll break down each model, explain who manages what, and show you how to choose the right one for different business situations. Once you understand those three models, you'll begin thinking like a cloud engineer instead of simply using cloud services. Knowledge becomes valuable only when you apply it. This week, create a cloud account, explore the portal, deploy one simple resource within the free tier, and then remove it when you're finished. As you work, ask yourself 3 questions. What did the cloud provider manage? What was my responsibility? What did I learn that I couldn't have learned by only watching videos? Write down the answers. Those notes will become the beginning of your cloud portfolio and the foundation for future interviews. Thank you for joining Hired in IT. Together, we're building the knowledge, skills, and experience that turn IT learning into real career opportunities.